Welcome, Desk of Ladyada.
Hey everybody, and welcome to my desk. We're doing all sorts of hardware hacking here this weekend. Let's get right into it. Let's go to the overhead and I'll show off some hardware. So one thing is we finally got the Qualia ESP32 S3 released, which means that if you want to do stuff with these cool, weird displays like round displays, bar, square, etc., anything with an RGB 666 40-pin connector, we now have this available. And we also merged in CircuitPython support. You can actually see the REPL here on the screen. So you can see the text show up there. If I can, it's kind of blurry. It's so bright. But this is a 480 by 480 display, and we've tested up to 720 by 720. So the demo I've got running here is from before I had the project that would go to the internet, get the geolocation IP address, and then download a different phase of the moon. And so here we've got a nice moon. Right now it's just showing the full moon, but I'm going to have it auto detect what the phase is. But the color looks much better now. Before it was a little bit greenish bluish because we were like using the wrong pins, and like I didn't realize that, and you can watch the previous videos. Also removed the NeoPixel because it was, we actually didn't even have an extra pin for a NeoPixel. We did the silk screen and fixed this so that the IO expander I2C address does not conflict with a capacitive touch overlay. Turns out like X38 is used by everything. So if you go back to the computer, I can show, so this is the sketch. So one of the things that you have to do when you have these displays is each one has its own initialization code over SPI. And the initialization has to be written over I2C using the expander, because we actually don't even have enough pins to have a separate SPI port. And so the init code, it looks very similar to like ST7789 or ILI 9341. It's just a bunch of commands and data to set like the resolution and the gamma, and it's all totally undocumented. You just kind of get this blob of text. You set up the IO expander, and one of the things we added is kind of native low-level support for IO expanders, and so you can use them. Like you can basically, without needing a driver, you set up this idea of a IO expander, and then you can like twiddle the bits directly. So it's one of the few drivers that is built into CircuitPython directly. Usually we have to like load a driver like the MCP 23017 or MCP 23008 or AW9513. But in this case, it's built in. So that's why you're like, hey, where's like the driver? It doesn't exist. We just initialize it with we just tell it like, hey, there's the address, and initialize it. And then you have to set the timings. So one thing that's really nice is we moved to IDF 5.1, thanks to Scott for doing the merge for that. And ever since we did that, the resolution is much more stable. Like it used to be that we would actually, if you set the frequency for the pin clock too high, the PSRAM couldn't clock out the data fast enough, and eventually you'd get like this like weird shimmery effect, or you'd get like chunks that were missing. As a 5.1, it's a lot better, much more stable. Like, I mean, pretty much rock solid. Definitely if you're loading from disk, the image will get flickery and staticky, but it doesn't happen for general use cases. And then, of course, we want verified that Wi-Fi still works with everything. Just, you never know. Like, as we go to IDF 5, a lot of stuff can break, but so far, so good. So it's kind of came together very nicely, and this will be part of CircuitPython 9. So if you go to CircuitPython, we like just merged these PRs, including one PR for these long bar displays. And one thing that I've learned about these long bar displays is that they often have offset, like overscans. The display thinks it's 960 by 600, but the memory is mapped oddly, so you don't get that full amount visible. It's a little kind of weird. And you have to initialize it, but you have to like write that much data. You can't like change, you can't send less data. It needs at least a certain number of pixels on the H-sync for it to synchronize, I guess. I don't know. I don't know what the deal is. And then, you know, we've been porting over all these init sequences for all of these funky displays. So thanks to Scott and Jepler, who've been like working nonstop to get that added in. But it's getting added in. Other news is 7051s are back in stock-ish, kind of, sort of. We're getting there. We got a shipment of chips, and so the Grand Central's been in stock. The Feather M4 is going to be in stock soon, and we're working on the Halloween M4. The Feather M4, the classic, is in stock right now. So if you've been waiting for these, we finally have it. Like before, we only got a couple hundred chips at a time, but this time we actually got a couple thousand. So we're able to fabricate a big chunk of these Feather M4s, and they're in stock. And we're going to see, you try to get the Monster Mask and the Halloween M4 in stock, hopefully before spooky season ends. So that's good. And then, you know, the big news this week is the Raspberry Pi 5 got announced. Note, it's not released, it's just announced. So, you know, people know about it, but it's not actually going to be available for sale for, I think, until at least the end of October. But it's pretty cool. You know, much faster chip, really interesting Southbridge, you know, this IO expander, that they designed. You know, like, I can tell that they probably tried to negotiate really hard with their USB hub and Ethernet and, you know, whatever other IO expander suppliers. But eventually, you know, for them, cost is kind of the most important thing. And in order to get the cost down, they designed their own silicon. So a pretty big deal. And still has the two micro HDMI, but adds a little UART connection, which is kind of neat. And then there is an RTC and then a battery that they're going to be selling that goes with it. And this allows it to, even if you don't have Ethernet or Wi-Fi, to keep track of time. You know, we have Pi RTC boards that you can use as well. You know, if you want like you know, ultra low power, like basically, you know, the whole thing can shut down. I don't know what the sleep current is for the Pi 5, but you can always use an external one. But what's nice is apparently it goes through the IO controller and then it can wake up from sleep, so it can actually handle the shutdown. And then speaking of shutdown, there is an on-off switch, which is like kind of a cool thing. Press the button to turn it on and off. And then because it's kind of a bigger chip, there is a fan controller that they have that they're selling with the case. And the PoE connector moved over here. So it's kind of nice because it was a little bit in the way up here. This way you can actually use bonnets and they're nice and flat. And then the really cool thing is that they've added this PCIe slot over here. So the camera and display, so they're now 4-lane MIPI, DSI, CSI. This is the same, I believe, pitch as the Pi Zero. So you'll have to use a Pi Zero adapter cable. It's not like the big chunky connector that we actually covered on the Great Search a little bit ago. And the PCIe is interesting because it allows you to use like disk drives, cellular modems, AI, like Coral, the Coral card, which lets you add more machine learning computation, like graphics cards, just like accessories. I think that comes with PCIe for your laptop or your computer is also available. So we don't do pre-orders because Adafruit never does pre-orders. We ship you the thing. We want to charge you when we have it available because, you know, you never know. But you can sign up, and then as soon as they come in, we will notify you and you'll get a shot to order it. It's going to be, of course, one order per customer. And then, you know, you'll need two-factor as well. But it's a good time. Set up your account, get everything ready, make sure your PayPal and credit cards all up to date, shipping address, so that when they come back into stock, you can check out immediately. And I think that's that. So let's get on to the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
A Great Search brought to you by DigiKey and Adafruit. Thank you, DigiKey. Every week, Lady Ada user powered of engineering help you guess you find the things that you're looking for on digikey.com. Ladyada, what are you looking for on digikey.com this week?
Well, in celebration of the Raspberry Pi 5 release, there is this new thing, the PCIe connector slot. And there's going to be an M2 hat that comes out. This has been announced from Raspberry Pi Trading Company. So you could plug in anything that has an M2 connection, which I don't have an M2 card here, I don't think. Oh no, I do. Let's go quickly to the overhead and I'll just show it off because I happen to have one. So this is what M2 looks like. This is this is a 2280 M2. And we covered M2 connectors before, but this is kind of, a thin PCB, and it snaps into, these M2 connectors. The notch has to line up, and then you could add, very common thing is adding disk storage, but also cellular modules are pretty common, like security tokens, whatever, accelerators and other configurations. So M2 is the physical format. PCIe is the standard of connectivity. So let's go back to the computer and I'll show that, because this was kind of mixed up in my mind. I was like, oh, is M2 and PCIe the same thing? No, but there's sometimes you can use M2 shapes with PCIe wiring. So PCIe comes in a couple different sizes. There's up here 4, 16, and 1. And the 1, 4, and 16 is how many lanes of differential data they carry. In this case, on the Raspberry Pi 5, if I'm not mistaken, it's a single lane, which is still plenty, like it's a lot. There's other lanes, but apparently they're used for other tasks, maybe to communicate with the South Bridge or whatever. So, however, this is just an electrical standard. This is a mechanical shape. So if you come down here and there's another PCIe, you can see a single slot. Let's see, go down. Okay, so they say like, okay, here's how many pins you get. I'm gonna just zoom out here. So if you have one lane, you only have like this 18 pin times 2 sides. So 36 pins total configuration. And then if it's 4 lanes, it keeps going. You have like another set of pins and it goes up to 64. And then if you keep going up to 8 pins, it's 49. So, 98. And then all the way, 16 full lanes, which is like some massive video card, you'd get 82 pins or 164 total. So what we want to do is we want to get a PCIe connector, and we can make a little adapter from the flex cable on the Raspberry Pi to PCIe 1X. So let's go to DigiKey and do that. So good news is that if you just type in PCIe, it'll actually come up with a bunch of edge board connectors, which is what we're looking for. So just take a look. Yeah, these look good. So one thing is I do want to have it stick up, not to the side, because some cards have like, they're meant to plug into, a motherboard. And so they're slotted and they can be a little wide. I don't want something that requires right angle connection unless, the PCB is cut over. I prefer to have it just be vertical and be done with it, because that way you can plug it in. And, what's nice is that you can get through hole as well as surface mount, but I'm going to be looking for surface mount. So let's start looking. We're going to look for active. And let's just start with that. So it's active and then like normally stocking and no marketplace. So we can just narrow it down already to 320. So the next thing is we need to know the card thickness. So it looks like there's like slim cards, or actually let's do the positions. So as we looked over, oh, sorry. Wikipedia. As we looked over here for 1X, it's 36 pins. So let's do 36 pins. And then card thickness, yeah, that's right. There's, it's basically one PCB thick. It's just card edge connect. And then we can decide how we want it to be connected. Do we want through hole like this or surface mount? I want to go with surface mount. So let's go to surface mount, although there is through hole as well. And then let's see what we got here. We got a couple options. What I like about this one is it even comes with a pick and place connector, but you can see it's got a nice solder retention, the big tabs on the side to make it sit in place. This one doesn't look quite right. This one looks good. Looks like there's actually quite a few options, which is kind of nice. I don't really care if it's, well, I guess we can get in tape and reel to start, not tray, because, you know, if we're going to pick and place it, I want to make sure that it comes in the right, in the tape. It'll be a very thick tape. Yeah, these all say pick and place, so that's good. Contact material, I don't really know if that makes a difference. And then let's just look at, you know, pricing. Let's see what's available. So this one I think is some odd thing, but this looks right. 36 pin position, you know, $2. Let's look at the 360 of it. Let's see if I load it up. Yeah, it looks nice, right? Like, oh, there's even a little board guide, big solder tabs, and then solder connections. So you don't have to tell people like, don't yank back and forth, just slot it down. But this connector would look really good and could would make for a nice adapter. So then all we need to do is make a PCB that takes the FPC connector that's used on the Pi 5 and just follow the pin out, wire it directly to the PCIe slot because it's just a mechanical change, and we're golden. So this is my pick from Amphenol, the PCI Mini Express SMT module.
And that's a great search.
Where in the world is that part I need? The great search with DigiKey.
Okay, that's our show for this week. We kept it 20 minutes. We're trying to get you in and out on the weekends because we know you got a lot to do. This week we want to do a recap, make sure we got the great search. Tons of stuff ahead this week. Thank you so much, everyone, for joining us. We will see you throughout the week.
Bye, everybody.